Welcome to electrical machine lecture. In the previous lecture, EMF equation has been discussed, and we come to across a formula, that is the EMF generated is equal to phi ZNP upon 60A, where A is the number of parallel path and where A is equal to 2 for the wave winding, and for lap winding A is equal to P. Okay, so we will proceed with the same topic with some examples or numericals. So this is the one example. A 4-pole generator having wave wound armature winding has 51 slots, each slots containing 20 conductors. What will be the voltage generated in the machine when driving at 1500 RPM, assuming that the flux per pole is 7 milliweber? So what are the parameters, or what are the parameters are given? One is the pole, number of pole P is equal to 4, and it is a wave winding. So armature is wave winding armature. So wave winding armature, it means that A is equal to 2. Now, how many slots are there? The number of slots is equal to 51, and 20 conductors per slots. So one slot carries 20 conductor. What will be the voltage generated in the machine? Means we are going to calculate EMF generated is equal to how much? Whereas the speed N is equal to 1500 RPM and flux per pole pi is equal to 7 milliweber. So which is equal to 0.07 Weber. So this is this one. Now 20 conductor per slots. It means that total number of conductor Z is equal to number of slots, number of conductor multiplied by, number of conductor per slots, number of conductors, number of conductor per slot multiplied by slots. So 20 multiplied by 51 equals to, so these are the number of slots. So it is equal to 1020 numbers. Okay. Now EMF generated equation, EMF generated EG is equal to phi Zn P upon A, isn't it? So put these values. Phi is 0.07 into 1020 into 1500 divided by 60 multiplied by number of pole is 4 divided by 2. So the EMF generated equals to 178.5 volt. So this is the answer. So this is one numerical. Second numerical is a 4-pole lap connected armature of DC shunt generator is required to supply the load connected. Number one is a 5 kilowatt geyser at 250 volt. Second is 2.5 kilowatt lighting load at 250 volt. The generator has armature resistance of 0.02 ohm. The field resistance is 250 and armature has 120 conductors in the slot and runs at 1000 RPM. Assume 1 volt per brush drop. Find flux per pole and armature current per parallel path. So what are the given parameters? Given parameter is P is equal to 4, means number of pole is 4. DC generator, DC shunt generator. So DC shunt generator. It is very much necessary. What type of generator is that? Now armature is lap connected. It is a lap connected. When it is a lap connected, number of parallel path is equal to the number of pole. Okay. Now, what are the loads? Load is 5 kilowatt geyser at 250 volt and 2.5 kilowatt lighting load at 250 watt, 250 volt, sorry. The generator has an armature resistance, RA, is equal to 0.02 ohm, whereas the field resistance, means it is a DC shunt generator. So definitely it is a shunt resistance. It is 250 volt. The shunt resistance is always higher because it is connected in parallel with the supply, whereas armature and series field resistances are very small because these resistances comes in series with the load. In the slots and speed, N is equal to 1000 RPM. Brush drop, there is a brush drop is there. Brush drop 2 volt because 1 volt per brush, and we are going to determine flux per pole and armature current per parallel path. So whatever the total current divided by the number of parallel path, how many number of parallel path is there? Because it is a 4-pole generator, and in case of lap connected, number of parallel path is equal to the number of pole. So divided by pole, for whatever it may be the armature current. So to determine the armature current, it is a DC shunt generator, so it is better to draw the circuit diagram. So we will draw a circuit diagram. First, we will draw the DC shunt generator. This is the brushes. Shunt generator. So field winding, it is connected in parallel. This is shunt field winding. And here is the load. Load, it is always connected in parallel. So there are two loads are there. So, okay, we will draw for two loads. One is the geyser and second is lighting load. So this is, say, 2.5 kilowatt lighting load. And where is 5 kilowatt geyser? 5 kilowatt geyser. So this is the load current IL. The voltage across load terminal is 250 volt. Okay, armature resistance. This is the generator, so it is having armature resistance. It is RSH. This is nothing but the ISH, and here is the low armature current IA, and we are going to determine, isn't it? So it is a very interesting and simple numerical. So what we will do, we will calculate the current in the load circuit. So total load is equal to 5 plus 2.5 equals to 7 point, it is equal to say 7.5 kilowatt, or you can calculate the current in the geyser as well as current in the lighting load. Okay, so we'll write as a geyser current is equal to, what is the load? 5 kilowatt. It is in kilowatt, so 10 raised to 3 comes into the watt divided by 250. So this is equal to 20 ampere. Similarly, lighting current. So it is 2.5 kilowatt, convert into the watt, 10 raised to 3 divided by 250 volt. It is equal to 10 ampere. So total current, total load current equals to 20 plus 10 is equal to 30 ampere. So see, in this case, say it is a 20 ampere, it is 10 ampere. Now here, if you apply the Kirchhoff current law, the total current will be 30 ampere, isn't it? Very simple. Now, what is the current in the shunt field winding? So shunt field winding current, ISH is equal to terminal voltage V upon RSH equals to 250 divided by the resistance is 250 ohm. So 250 equals to 1 ampere. So what is the armature current? Therefore, armature current equals to IL plus ISH equals to 31 ampere. So this is one parameter. We want to calculate the armature current. Now, our objective is to determine the armature current per parallel path. Armature current per parallel path. Armature current per parallel path is equal to 31 divided by 4. Since A is equal to P, which is equal to 4. Okay. So it is equal to 7.75 ampere. So this is the first parameter, one parameter we have determined. Now, EMF generated. Next parameter is flux per pole. So to determine the flux per pole, it is very much necessary to determine the generated EMF. And from this generated EMF formula, we can determine the flux per pole. So EMF generated EG is equal to. Now, if you apply the Kirchhoff voltage law, so it is the EMF generated, the current is flowing IA, some resistance is there, brush drop is there, and this is the terminal voltage. So we can write as VT plus IARA plus brush drop. This equation or this concept already discussed. So it is equal to 250 volt plus 31 point. What is the armature resistance? Armature resistance is given as 0.2 plus voltage drop is 2 volt. So it is equal to 258.2 volt. Now, EMF generated is equal to pi Zn P upon 60A. Here P and A is same. So we will just put the values. EMF generated already calculated 258.2. Flux we want to know. Number of conductor. Z is the total number of conductor. So just see what is the given in the numerical. How many conductors are there? 120 conductors. Here Z, one more parameter. Z is equal to 120. It is given. So Z is equal to 120. 120 multiplied by speed. Speed is given 1000 RPM. And P and A, okay, we will write P and A as it is. So it is divided by 60 multiplied by 4 upon 4. So this is the flux. So flux is equal to 129.1 millibar. So this is the second parameter as per the question. So in this way, there are other numericals are there. One may refer the different book like Electrical Machine by P.S. Bhimra, and or you can refer the Electrical Machine by Ashfaq Hussain or other books, Nagrath Kothari, like that. One more numerical, a 4-pole long shunt lap wound generator. So what is given? It is given that number of pole P is equal to 4. Long shunt lap wound. So it is a lap wound. So A is equal to P. Okay. Supplies 25 kilowatt. So load PL, it is given load resistance or sorry, load, it is given 25 kilowatt. At terminal voltage, it is given 500 volt. The armature resistance RA is equal to 0.03 ohm, whereas the series field resistance RSE, it is equal to 0.04 ohm, and shunt field resistance RSH is equal to 200 ohms. The brush drop, so brush drop is equal to 2 volt, and speed of prime mover, calculate the number of conductor if the speed is, so we are going to calculate total number of conductor, whereas the speed is given 1200 rpm. Anything? Yes. Flux phi is given, it is 0.02 wave. These are the parameters. So as it is a long shunt generator, so it is better to first draw the circuit diagram for the long shunt generator, and then we will determine other parameters. So this is the long shunt. It means that shunt winding in parallel with armature as well as series field winding. So here this is the long shunt. So this is the long shunt. What is the load? Load is 25 kilowatt. And terminal voltage is 500 volt. Series field resistance is 0.04. Armature resistance is 0.03. This is the ohm. And shunt field resistance is 200 ohm. So this current will be ISH. This current will be the load current IL. And the current delivered by armature is IA. Okay. So now we will try to calculate. So first, it is better to calculate the load current. Load current IL is equal to 25. Okay. 25, or you can write as load in watt divided by terminal voltage. So how it is? Because it's very simple. Load PL is equal to VT into IL. Therefore, IL is equal to PL divided by VT, but the watt load should be in watt. If it is in kilowatt, you first convert into the watt. So it is 25 into 10 raised to 3. It is in watt divided by 500 equals to 50 ampere. Shunt field current. Shunt field current ISH is equal to VT upon RSH, because same voltage, whatever the voltage is here, same voltage is going to appear across these two terminals, because load, shunt field resistance, and this armature circuit all are connected in parallel. So it is equal to 500 divided by 200. So it is 2.5 ampere. So armature current armature current IA is equal to IL plus ISH. So 52.5 amp is the armature current. Now EMF generated. EMF generated. So now whatever the EMF generated over here, some voltage is going to across this series field resistance IA into RAC and voltage across terminal. So which is equal to EG equal to terminal voltage plus IA RA plus IA RSE plus brush drop. So it is 500 plus 52.5. Since armature resistance is there, so we can add these two quantity 0.03 plus 0.04 plus 2. So EMF generated EG equals to 505.67. So this is the EMF generated. Now EMF generated EG equal to pi Zn upon 60 into P upon A. Yes. So it is a, which type of generator? It is a lap or wound. See, this is the, it is a long shunt lap windings or lap connected. So A equals to P. Since armature is lap connected. Okay. So EMF generated is 505.67 equals to, flux is given. Is it given flux? Flux is 0.02. 0.02 into Z, number of conductor, speed is 1200 RPM, 1200 divided by 60 into T and A is same. So it is okay, we'll write as a number of pole is 4. Number of pole is 4. So it is 4 divided by 4. And therefore the total number of conductor Z equals to 1,264 numbers. So this is the answer for the third numeric. So in this way, we can do other example. And next time we'll see the next topic of the DC generator. Thank you.